Good morning, or I guess afternoon, geometry students. We are going to be doing lesson 3-1. So our learning target for today is I will be able to find pairs of lines and name angles. All right, so we've got a little warm up here. So pause the video and do these 4 questions here, and then resume your video, and then go ahead and see how you did. So number 1, points that lie in the same plane are called what? And they are called coplanar. Number 2, 2 angles whose sum is 180 degrees. Those are called supplementary angles. Number 3, the intersection of 2 distinct intersecting lines. Well, what do they intersect in? And they intersect in a point. And a pair of adjacent angles whose non-common sides are opposite rays are called a linear pair. All right, moving on into today's lesson. They just want you to look at this without falling over because it's craziness. Are the lines, gray lines, parallel? So what do you think? Are those gray lines parallel? So if you look at this gray line, oops, my pen's not working. If you look at this gray line, is it parallel to this gray line? Is it parallel to this gray? Whoops, didn't trace that one very well. Parallel to this gray line, to this gray line, to this gray line. What does it look like my purple lines? Do my purple lines look parallel? Craziness, huh? All right, so what are parallel lines? Okay, stop and think about that for a moment. So in the classroom, the answer that I get for parallel lines typically is 2 lines that never intersect. So 2 lines that never intersect. So now let's think about that. And if you think about a line, like look at these airplanes right here, airplanes that never intersect. So if we have a line on the ceiling of a building, like any kind of ceiling, and then you put a line on the floor and it's not going the same way, are they necessarily parallel? So if we do one on the ceiling that's going this way, and we do one on the floor that's going this way, are those parallel lines? No, they end up being skew. So one big thing that we have to put in our definition for parallel lines is the fact that they need to be in the same plane. So some of you are going to need to stop this screen right here and then copy down this stuff that's highlighted in green or yellow. So what's the definition of parallel lines? And then you can see the symbol right here for parallel is 2 lines that go like this. They must be coplanar and they do not intersect. Definition of perpendicular lines, so you can see the symbol here in yellow. This is your symbol that we use for perpendicular lines, the capital upside down T. Perpendicular lines intersect at 90-degree angles. So now in the third one, the green one, skew lines, they are not coplanar and do not intersect. So make sure you include coplanar or not coplanar to know the difference between parallel and skew lines. And then the fourth one, we're talking about parallel planes. Those are planes that will never intersect. So kind of like the floor and the ceiling in a building. Those would demonstrate planes that will never intersect. All right, so looking at this diagram here, they want us to say this all in relation to point A. So not all of the ones, but they want your answer to contain this point A. It just cuts down on the number of answers that you can have. All right, so we want it to be parallel to CD. So the only line that's going to be parallel to CD that has point A is going to be line AB. Remember, capital letters and arrows on both ends. The line or lines that are skew to CD, so again to CD, has to have point A in it. So what lines would they be? Well, skew, you would have AH, and to be honest, I would let you go with segments or lines here, but because they're saying right lines, I'm going to write it as AH if it were a line going on forever. And then also AG is going to be skew. Line or lines perpendicular to CD that contain point A. So AG D is the only one that is going to be perpendicular. Plane or parallel to EFG. So EFG, that's the bottom plane, so it's like the bottom of the box. So the only plane that is going to be parallel to it is going to be something like plane ADC. Now you could have said plane ADB. As long as you have that A in there, you are okay. So you could have also said plane A, C, and B. So as long as you have 3 capital letters and the word plane in front. All right, looking at this next diagram, just going ahead and just coming up with a few things. So looking at these red segments, what would you say those red segments are? And we're going to say those are parallel. So what would we say about the green ones? Look at those green dotted lines in the back, and those are perpendicular. And how about the yellow ones? Are they parallel, perpendicular, or skew? And looking at the purple ones again, we're going to have a repeat here. So the perpendicular ones, because this is a cube, they are going to be perpendicular. All right, a couple theorems or postulates that we're going to go over here. The first one is called the parallel postulate. And so what that parallel postulate says is if we have a line, like this line L right here, we have line L, and we have a point not on the line, like this point P, then there is exactly one line that's going to go through P that will be parallel to the given line. We cannot draw more than one. There's only going to be one line going through P that will be parallel. And something new that we maybe have not talked about yet this year is the fact that, do you see these arrows right here that are on the both lines? Those mean parallel. Those 2 marks mean parallel lines. Okay, that's how we mark it on the diagram. If we're writing it out longhand, we'd say L is parallel to line M, let's say. So the symbol would be this way. If you're actually on a diagram, then we do these lines. All right, the second postulate here is called the perpendicular postulate. So again, they're saying if we have a line, like line L here, and we have a point P where P is not on the line, then there is exactly one line that goes through P that will be perpendicular to L. So we have this line right here. So these are the parallel and perpendicular postulates. All right, here we've got a couple of lines. The 2 red lines here, they're definitely not parallel, they're not perpendicular, but we have a line, the green line here, that is going through 2 other lines. This green line has a special name, and we call this a transversal. So a transversal is a line that is going to intersect 2 or more lines. So if we had 3 lines here, the transversal would be the last one going through. This line right here is what we would probably consider our transversal. It's intersecting 2 or more lines. Now, when we have something like this, we have some angles. 1, 2, 3, 4, 5, 6, 7. We have 8 angles. So we have 8 angles listed here, and some of these have names that we've already talked about. So 1 and 3, what kind of angles do we call 1 and 3? So 1 and 3 are considered vertical. So that's not going to change. We still have that name. Okay, 1 and 2, what would we call 1 and 2? Well, 1 and 2, because they're adjacent, share a common point, and are supplementary, we would say that these are a linear pair. So all those names still hold true. But then we have different angles, things going on here that are going to be like 1 and 5. Okay, so if we talk about 1 and 5, what are 1 and 5? If we talk about 8 and 4, what are 8 and 4? 7 and 8 have a special name, and 1 and 7. think that about covers it. 1 and 7. So there are different names that we call these, and we all talk about them in relation to the line that forms them and the transversal. All right, so all of these angles are going to have special names. So if we look at them according to their line and their transversal, we can name them. So if you look at 1 and 5, look at those two red lines, and we have exterior angles. So if we're talking about exterior angles, 1, 2, 6, and 5 are all exterior. They're on the outside of those red lines, where we would say the interior angles are going to be 8, 3, 7, and 4 are going to be your interior angles. So now if you look at 1 and 5, what those are considered to be are alternate exterior angles. Alternate exterior. And if you look at 8 and 4, you see how they're on the inside, but they are still alternate on opposite sides of that transversal. These are called alternate interior angles. All right, if we look at 7 and 8, those are called consecutive, S-E-C-U, consecutive interior angles. We do not have consecutive exterior angles because those interior angles are in between them, so they wouldn't technically be consecutive because there are angles in between there. So 1 and 7, those are called corresponding angles. S-P-O-N-D. Oh, I'm running out of room. Corresponding angles. Corresponding means they are in the same exact place, according to line and transversal. According to line and transversal. So if you look at this line and this line, both 1 and 7 are above the line, and they're both to the left of the transversal. That's what I mean by same place. So if we look at 3 and 5, do you see how according to the lines, they are both below the line, and then they're to the right of the transversal. That's what I mean by same place. So if you need to, pause this and move on. All right, so alternate different sides, consecutive same sides, corresponding, they are matching. So let's look at a couple of them. Alternate interior. So this one and this one are going to be alternate interior. Alternate exterior is going to be this one and this one. They are both on the outside of the red lines and then alternate from each other. Consecutive, this one and this one are consecutive, along with this one and this one. Remember, we don't have consecutive exterior. Corresponding would be like this angle right here and this angle right here. They're both below the red line and to the left of your transversal. Vertical, we've already talked about those. Those are do not change from what we have been talking about before. And here, if you want to pause this, this can give you a more exact definition of everything here. But that's, again, it's just going through some examples. So pause it if you need to. If not, just go ahead and move on. All right, so now we're just going to practice a couple. So if we're talking about 11 and 13, what I like to do is trace 11 and trace 13. Do you see how both of these lines have this one in common? That is considered your transversal. The one that both lines have in common is considered your transversal. And if you look at 11 and 13, they're both interior. So now, are they alternate interior or consecutive interior? All right, so now let's look at the second set they have here, 2 and 11. So we've got 2 and 11. So do you see how this one right here is the one they have in common? That's what the transversal would be for that pair. Now, if you look at that, 2's on one side and 11's on the other side. So these are called alternate interior angles. All right, you guys should be ready for your assignment. Good luck on this lesson.